Okay, let's say you have 2 points in the coordinate plane, any 2 random points. Call the first one x1, y1. Those are not exponents, they're subscripts, they're just saying it's the first x and the first y. And somewhere out there, I guess I'll make a random coordinate plane here. Somewhere out there in the rest of the coordinate plane, there's another point, x2, y2. And we would like a formula for finding the distance between those 2 points, or what's the same thing, the length of the line segment joining those 2 points. So what we can do here is kind of turn this situation into a right triangle, because we don't know the diagonal distance off the top of our heads, but we can see what the horizontal distance would be. All we'd have to do is find the difference between the first x value and the second x value. We could represent that with x2 minus x1. The vertical distance between the points could be found by doing y2 minus y1. And because this is a right triangle that we're dealing with, we can apply the Pythagorean theorem. So it would be, this is your A, this is your B, and what you're looking for, the distance between the points, let's call that D. So it would be x2 minus x1 squared plus y2 minus y1 squared equals D squared, just from the Pythagorean theorem. But because ultimately we're not looking for D squared, but we're just looking for D, that distance, we're going to undo the squared by square rooting both sides. So the distance D between the 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is what is known as the distance formula. Typical question is, does the square root undo these 2 individual squares here? That's like saying that if you have the square root of 9 plus 16, that's the same as the square root of 3 plus 4, which is not true, so no. That's big square root does not undo those 2 little squares there.